Everybody, today we're looking at quadratic domain and range. Um, trying something new. We got screenshots from Alex just to make it a little bit easier for those of us who get confused from the notes and connecting it back to the work. So for this first case, it's asking us about the graph of our quadratic function. So just a reminder from Algebra 1, the quadratic graph is a parabola, as you can see here. It's also telling us that the vertex is at -1, 4. And the vertex is this point. On our vertex where it changes from increasing to decreasing or from decreasing to increasing. So it's just asking us about our domain and range. So if we look at our graph here, we notice that our parabola goes in this direction. Where our vertex is located, that will determine our domain and range. So notice that this one, when a parabola has the two arrows pointing downwards, this is opening downward. And anytime we have an open downward, the vertex is gonna represent the highest point on this graph. So this is going to be a maximum. So these are things we want to note before we start filling this in. So the domain for any quadratic function, notice the arrows go in both directions, technically forever to the left and to the right. So this is going to continue on in both directions forever. So our domain is going to be all reals. So domain is all reals. Another way to think about that is we can put any x into a quadratic function and get a y for an answer. So that's why our domain, again, when we talk about our domain, that's our x values. The domain is going to be all real numbers. Now our range represents the y value. So if we're looking at our graph here, we kind of just said that the maximum is at this vertex here. So when we set up our domain, we're going to say that y, notice the graph is underneath the vertex, right? So everything on the graph is at or below the vertex. So we're going to say y is less than or equal to, and we're taking the y value for the vertex. So oops, that should be a -4. -4. All right, so we take the y value from our vertex. And if it's below, like we have here, we'd say that it's less than or equal to that number. Now, if we had a case where we had a vertex like this, then we'd say that our range is y is greater than or equal to whatever that number is. In this case, it looks like it's at 4. So we'd say for the range for that purple one that y is greater than, because it's opening upwards, or equal to +4. All right, so this next example, it's giving us the equation. So our equation is y is equal to 3x squared plus 6x minus 1. It's asking us to find the range of this function. So there's going to be a little bit of process for this, and it's going to follow the same steps every time you do it. But let's just go ahead and start doing it. So I'm going to write this a little bit bigger for those of us who have a hard time seeing. So y equals 3x squared plus 6x minus 1. All right, so the first thing we want to do is we're going to use this formula. X is equal to -b over 2a. So what this is going to do is going to help us to find the x value. It's going to find the x value for the vertex. All right, because like we did in the last one, if we can figure out where the vertex is and which way it opens, then we can tell what the range is here. So it's asking us again, find the range. All right, so let's plug in our stuff here. So when we have a quadratic function, if you guys didn't already do this in Algebra 1, we have an a, which is the number next to your x squared. We have a b, which is the number that's next to the x, and we have a c, which is the constant. It doesn't have a variable on it. So when we're filling in our x equals negative b over 2a, we're getting these numbers from our function. So we have the a is 3 and the b is 6. So we're going to say x is equal to negative b is 6, right? So I'm going to put in parentheses 6 over 2 times a is 3. We're going to simplify it. So we have a negative sign 6 divided by 2 times 3 is 6, which is equal to negative 1. So we know our x is negative 1. We finished our first step. All right, so what we're going to do with that negative 1, that's our x. That doesn't tell us our range yet. So what we're going to do is we're going to find the y for our vertex. The y for the vertex. Forget how to spell. For the vertex. And we're going to find the y for the vertex by substituting the x that we just found into the equation. All right, so our x is negative 1. We're going to plug negative 1 into all of our x's in our equation. So y equals 3. It's a good idea to put parentheses, whenever we substitute. So negative 1 squared plus 6 times negative 1 minus 1. Well, negative 1 squared is positive 1 times 3 is 3. Plus 6 times negative 1 is negative 6 minus 1. So 3 minus 6 is negative 3 minus 1 is negative 4. So y equals negative 4. All right, so the y is going to tell us for our vertex. That's going to be helpful in our range because our range is all the y values. Now the last thing we need to do is determine if this opens upward or downward. Now the key to this one is our a. So if a is positive, then it opens upward. If a is negative, then it opens downward. So that kind of tells us about our range. So we know that our y is 4. Our negative 4, sorry. And we know because our a is positive, we have positive 3, that it opens upward. So if we have a graph that looks like this, our y value for there is negative 4, then we know that when we fill this range thing out, we're going to say y, because it opens above that point, our vertex, is greater than or equal to negative 4. All right, step 1, find our x. Step 2, use that x, substitute in, find your y. And step 3, determine, does it open upward? Is it positive for a? Or does it open downward? Is it negative for a? And then do your range from your y. All right, we're going to do one more example here. For this one, let's say we have y equals, actually, let's not do that. The example is a little bit different. So let's say that we have 2x squared minus 12x equals negative 21. All right, so sometimes they like to trick you. Notice this one. We have this equal sign, and we have the number on the other side. All right, I'm trying to find the range again. All right, so when we have this, what we want this to be is, if it's not y equals, what we want this to look like is for it to equal to 0. So the first thing we need to do here before we clean this up, we're going to add 21 to both sides. And then now that we do that, we have it equal to 0. So we have 2x squared minus 12x plus 21 equals 0. Okay, at this point, you can even label your a, b, and c because we know we're going to be using that. So our a, again, is the number that comes in front of your x squared. Your b is your x term. And then your c is the constant. And then we're going to just follow the steps again that we did in the last one. So step 1, we're going to say that x equals negative b over 2a. So we have negative, b is negative 12. Be careful with that double negative there. And then 2 times a is 2. All right, so the double negative is positive. 12 divided by 4, which is 3. Step 2, we're going to take that 3 and substitute it into our equation. Let's just use this one. It's a little bit simpler. So we have 2 times 3 squared minus 12 times 3 plus 21. Instead of saying is equal to 0, we're going to say is equal to y because we're trying to find our y. If we plug in a 3, so then we get 3 times 3 is 9, times 2 is 18, minus 36, plus 21. 18 minus 36, negative 18, plus 21 is 3. That's interesting. Our x and our y are 3. Okay, in step 3, we're queuing in our a. Our a is positive again. So we know that we have a parabola that opens upwards. So we're going to say that y, because it's greater than the vertex, is greater than or equal to the y value, which is 3. That's how you do your range. I'm not sure how much you guys did domain and range in Algebra 1, but it's something that's going to keep popping up over and over again as you guys get higher levels of math. So I want to make sure that we understand what the range and the domain is. Again, domain covers all the x values that are possible to plug into your function. The y is all the possible y values that can come out of that. So it's a good starting point to talk about domain and range when we're talking about parabolas, because there's definitely a maximum or minimum for each of our parabolas, as opposed to linear stuff, because linear stuff goes on forever in both directions for your x and your y. So it's not really good because it's not really domain or range restricted. It's all real numbers for all of this stuff.